Hi, I'm Paul Roberts and I'm a chemistry teacher here at Andover College. Today I'm going to talk you through how to do core practical titration of acid and alkali. Now this is a real classic chemistry experiment, and if the students pay particular attention to the measurements along the way, they should get some accurate, reproducible results. Now before we start the experiment, we have some safety considerations. First of all, we have our sodium hydroxide. Sodium hydroxide has a concentration of 0.1 moles per decimeter cubed. Its concentration, it is an irritant, and it is also corrosive. If any spillages occur on the skin, you need to wash your hands straight away and be very careful not to get this in the eyes. Any contact with the eyes will require immediate medical attention. Likewise, we have a concentration of hydrochloric acid with a similar ballpark number to the sodium hydroxide concentration. It's going to be approximately 0.1 moles per decimeter cubed. Again, it's corrosive and irritant at its concentration, so eye protection and lab coats need to be worn throughout the practical. So to start the titration, let's consider the hydrochloric acid. Now the hydrochloric acid is of an unknown concentration. So now I'm going to charge the buret with hydrochloric acid. Now it's very important that I check that my buret tap is closed. It's closed in the horizontal position, and a very important safety aspect is that burets must always be filled below eye height. Filling a buret, reaching above your head to fill a buret, is dangerous because even with safety glasses on, there's a risk that you can pour the acid over your head, and that is not a good idea. So in my situation, I'm going to place the buret on the floor and fill using a small funnel. You want a small funnel so it's difficult to accidentally overfill the buret, and ideally the funnel wants to have a narrow bore so it doesn't accidentally get jammed in the mouth of the buret. Now I'm going to fill the buret with hydrochloric acid. I'm using the stock bottle here, but it might be an idea for students to decant this first into a 100ml beaker and then add from there. So I'm adding it in there, my tap is closed. I'm just keeping an eye on the level. It will fill a lot faster than you expect. I'm going to fill to just below full and then move the buret back to the table. I'm going to rinse the buret. First adjust the height a little bit, and I'm going to drain the acid out of the buret. Now this serves two purposes. First of all, any debris that may be in the buret will be rinsed out. Also, it should clear any air bubbles that are in the jet of the buret. This may take a little bit of time, but it's a very good practice to do to get good reproducible results. Now I'm not going to empty the buret completely. If I do that, there's a chance that I'll create an air bubble in the jet. So I'm going to wait until the buret's round about 50, and then I'll move it back down onto the floor and I'll refill. So I'm turning the buret off, and this is now my waste beaker. This beaker, like all chemicals in this reaction, can be disposed of down the sink with plenty of water. So now I've rinsed my buret, I can refill it, and again, in my situation, I'm placing this on the floor. I'm going to take my hydrochloric acid, and I'm going to refill. Now, it's not essential to hit exactly zero on the buret when refilling. In fact, you can waste a lot of time to hit zero. So I'm going to stop so I can clearly see that my acid level is within the scale of the buret. I've also this time removed the funnel. It's important to remove the funnel from the buret, as any drips that might take place during the titration will affect the actual titer value. Okay, so now my buret is full of acid and clean acid. I'm going to move back onto my table. So now the buret is full, we can move away to the hydroxide side of the titration. This requires a pipette volume of 25 centimetres cubed. Now I'm going to insert the pipette filler onto the pipette, and again there's a very safe way to do this and there's an unsafe way. When inserting the pipette into the pipette filler, it's very important not to push the pipette at any distance into the filler. If you were to push the pipette into the filler in this arrangement, there's a chance this glass here could break and the broken glass goes into your hand. This will most certainly result in a trip to A&E. Alternatively, insert the pipette into the pipette filler first by loosening the ferrule at the end of the filler and gently rotating the pipette filler onto the pipette, not the other way round. Now, if this were to break at this moment, there would be no injury. Okay. Just inserting it on, smooth pressure. Now, in some cases, teachers may want to do this for their students. Now, I can be sure that my pipette filler is firmly attached to the pipette, turning it upside down and gently pulling on the filler, and there should be a positive pressure. Never the other way round, because if it falls out, you'll have broken glassware. Now I'm going to fill the pipette with my sodium hydroxide. Now, in the same way that we rinse the buret, I'm also going to rinse the pipette. I'm rotating the wheel of my pipette filler, filling the pipette, and then push the button and just let the pipette empty. And this is essentially just rinsing any dust or debris or any other chemical residues that may be in the pipette. Now I can accurately measure out 25 centimetres cubed of the hydroxide into a conical flask. Now, before I start this, I want my conical flask to be as close to my hydroxide as possible. This is going to minimise any drips on the table. I'm making sure the wheel is pushed all the way down, and then I'm going to draw up. And this is the part that the students will probably find the most challenging. Now, what I do at this point is I purposely go past the meniscus endpoint here. This is my endpoint, 25 centimetres cubed that I'm looking for. I purposely go past. I lift the pipette out of the solution, and I then gently roll down on the wheel until I get to my meniscus pointing at 25 centimetres cubed. And then I can transfer across into my conical flask. Now, the students at this point have a temptation to push down on the plunger and empty out the pipette. Now, unfortunately, doing that actually releases too much hydroxide. The pipettes are designed to have a very small volume of solution or a very small volume of liquid in the bottom. If you want to make sure that there are no drops coming out the bottom, you can just touch it to the base. But all the time I'm making sure my thumb is on the button, so letting gravity drain the pipette. Okay, so that's now my 25 centimetres cubed of sodium hydroxide accurately measured. We can now start the titration. Before we start, however, we need to make sure we can see a colour change of the titration. So I'm putting a white tile on the base of the buret. Now, this titration has an indicator of methyl orange. And I'm going to add 5 drops of methyl orange to my sodium hydroxide solution. If you add a few more drops, it's fine. You just don't want to go adding squirts and squirtfuls. Okay, so this is the starting colour of the titration. Is a kind of a mild orange colour, and I'm now going to adjust my buret so it's just, the jet of the buret is just inside the conical flask. I don't want the buret to be too low. If it's too low, then it's going to be difficult to stir. If it's too high, then some acid might not actually find its way into the conical flask, and that will give bad results. Now, I've already taken my initial reading. At this point, it's worth checking that your initial reading hasn't changed. I've checked this, and my initial reading is still 0.8 centimetres cubed. So as we're going to be looking for a colour change during this titration, and the colour is going to be starting as a orange colour, in the methyl orange, and it's going to be turning to a light pink colour. Now, as a tip, what you can do is prepare another flask of 25 centimetres cubed of sodium hydroxide, add the same amount of methyl orange indicator to it, and use this as a reference start point. That way you'll be able to easily see that your titration has changed colour. If we were doing the same titration using phenolphthalein as an indicator, we'd expect a colour change to go from pink to colourless, and in this case we wouldn't actually need a reference point. So I can now start running acid into the conical flask. I'm turning the tap to the vertical position, and you want a nice steady flow. Now, this is a technique that's been developed over many years. I want to try and swirl my conical flask whilst having the tap open. The tap is open, acid is running in, and I'm looking for a colour change. At the moment you can see there's been no colour change from the initial. Notice I am not looking at the graduations in the buret. I'm just focusing on the colour change. Checking my reference. I'm now just starting to see a slight pink change of colour. But when I stop the buret, that pink colour disappears. So I'm now getting close to my end point. I'm turning my tap very slowly, and I've just got it going on a drip wise, and I'm looking for a change of colour. Okay, now notice I still have the same colour as the starting colour, but I'm now very close. That pink colour remained for quite a while. At this point, I want to accurately release 1 or 2 drops at the most, using both hands on the buret tap, letting 2 drops. The solution's gone pink. I can swirl that colour pink, slowly faded away. I'm getting now very close to the end point. I'm going to do the same again. Add 2 drops maximum. 1, 2, and then swirl. Notice that colour has almost changed. It's very close to that pale pink end point. Again, 2 drops. 1, 2. And you can see now we've reached the end point there. And comparing the starting colour with the final colour, we've got a very faint, some people describe this as a salmon pink type colour. And so this is now the end point of the titration. So I can now read the end point of my buret. And reading from the bottom of the meniscus, I can see it's 22.8 centimetres cubed. So not only do I have an end point reading, I also have a start point reading for my next titration. At this point, you might consider refilling the buret, but only 22 centimetres cubed of acid has been released, and the total volume of the buret is 50 centimetres cubed. That means there's another 28 centimetres cubed remaining in the buret, so there's enough volume left behind to enable another titration without having to refill. This will speed up the titration process. And going back to my earlier comments about the concentration of your unknown acid, this is why if you keep your concentration of the unknown acid to be slightly higher than 0.1 moles per decimeter cubed, that means you'll need less acid to complete the neutralization, and so you'll be able to get more than one titration of acid out of a single 50 centimetre cubed buret. So now we've reached the end point of the titration, I'd like to show you what would happen if you delivered too much acid. As you can see here, instead of reaching an end point of a salmon pink colour, we'd end up with more of a rose pink colour of solution. And in this example, too much acid has been added, and unfortunately it would be considered a poor quality titration. We won't just do one titration in this situation. We typically look to repeat the titration to get concordant results. And by concordant results, that would be two titers having volumes within 0.2 centimetres cubed of each other.